Hey there, welcome back. Today we will talk about reentrant lock. Now, as the name suggests, reentrant lock is a locking mechanism, and using this lock we can definitely apply a restriction, apply a lock on multiple threads so that they cannot run simultaneously. Alright, so now using a very simple example, let us try to understand the usage of reentrant lock. Now, in order to understand the concept, let us add in a static entity first of all. Static, it would be a int variable. Name of the variable would be like counter, and we will initialize this with 0. Pretty standard stuff, right? And now in here we will create thread. So I will type in thread1 equals new thread, and we will make use of runnable interface. Here we go. And inside this run method, we will add in a for loop. So we will type in for int I equals 1, I is less than equals to 1000, I plus plus. And inside this loop, we will simply increase the value of counter. So we will type in app.counter plus plus. Alright, so this is good. Let me copy this fragment of code to be more specific and paste it once again. And this time we will give the name to thread as thread2. Alright, and once we have done both of these stuff, we will type in thread1.start, then thread2.start, and then we will add in the join methods. So in here I will type in thread1.join so that our main method waits until thread1 and thread2 completes its execution. We have already covered the concept of thread, if you guys remember. And then finally we will simply print the value of counter. So in here we will type in the final value of counter is, and then we will print the value of counter, app.counter. So pretty standard stuff, right? And now if I execute the program, as we know that there might be some interference in between these two thread 1 and thread 2. So the final value won't be like 2000, it could be anything else. It could be 2000 sometime, it could be something else, and there should be some kind of inconsistency as we can see. And this is because there are inconsistencies and interference. Both of these threads are simultaneously trying to increase the value of counter, and as a result there could be some kind of issue. Now the solution of these issue is we can apply the concept of synchronization, right? But now we will make use of the reentrant lock. Now friends, in here for sake of simplicity I am creating a static reentrant lock. You can make use of non-static reentrant lock and pass them as a parameter as well, it's up to you. So in here I will type in static lock equals new reentrant lock. Here we go. Now in here there is some kind of issue. Let me fix this. Let me hover upon this and let us add the required import. So now everything seems to be good enough. Now if I execute the program, definitely there is interference. Now friends, whenever we work with locks, always try to understand what is the common entity, what is the root cause of this interference. In here the root cause is this particular counter variable. And whenever we are applying an increment operation on this common entity, there could be an issue. Now there is again a catch. In here we are working inside a for loop. For example, if I directly apply the lock in here directly on this statement which says app.counter plus plus, definitely there would be locking and unlocking per iteration, and that could be time consuming process. So the best thing which we can do is we can apply lock for this for loop itself. So let's do that. So before the for loop we will type in lock. So we are locking this particular fragment of code, and then we will apply lock.unlock. We will do the same with this particular thread 2 as well, because there could be a scenario where thread 2 start execution before thread 1, and in those kind of scenario we will again get some unexpected result. So in here we will again say lock.lock, and after this for loop we will again say lock.unlock. Now friends, what this lock.lock method will do, whenever we call this lock method on the object of reentrant lock type, a reentrant lock would be applied, and the code after this lock method call would be executing in a single thread, and no simultaneous thread will get executed unless we call in the unlock method. So we are applying a lock so that other thread cannot execute simultaneously, and once our work is done on the common entity, we can definitely apply the unlock method. And as we are applying the lock on both the threads, definitely we would be able to see that now there won't be any interference on our common entity, and every time we will get a consistent result of 2000, which is cool, right? Now friends, what's the benefit of reentrant lock? Definitely the first clear benefit of reentrant lock is better control. When we are making use of lock method and unlock method manually, we have a better control and it's all manual, right? So we can apply lock, we can unlock the thread based on our requirement. It's all manual, we have better control. The second significant benefit is there could be some scenario where our multi-threaded application enters into a deadlock scenario. Definitely deadlock is not a good thing. Your program will stuck somewhere, it would be hanged, and nobody wants that. In order to prevent deadlocks, reentrant lock could be useful. We will definitely check what exactly is a deadlock and how we can make use of reentrant lock in our future video. So these are the two things. Moreover, there is an issue with the current program. The issue is that there could be some scenario that we won't be able to execute this unlock mechanism, and our lock would be locked on a specific thread infinitely. Now, what is this scenario? Imagine if inside this for loop we encountered with an exception. In those kind of scenario, lock won't be released because we won't be able to call the unlock method, and as a result our program would be stuck infinitely until the program gets terminated, and that's bad. In order to understand and ensure that our unlock mechanism will always work, it is always good idea to make use of the finally block. Now whatever is the code which is in between call to lock method and call to unlock method, in our case this for loop, so this for loop is in between lock method call and unlock method call. So whatever is the code which is in between lock method call and unlock method call, try to keep it in between a try block so that we can handle the exception properly. Here we go. Let me format things a little. Now friends, making use of catch is optional. We will make use of finally directly, and we will keep the call to unlock method inside finally. Now friends, we have kept the call to unlock method inside the finally block. Now this applies that we can now guarantee, we have ensured that the call to unlock method will always happen regardless of any exception inside the try block. So that's one thing, and definitely we would be able to unlock the lock. So that's one thing, and this is the way how we must make use of lock and unlock methods. So let me do the same, and I will copy this part of code and paste it in here. Here we go. So this looks good to me. Alright, so I suppose there is a missing brace. Let me fix this. Alright, so this looks good, and now if I execute the program, definitely there won't be any change in the output, and every time we will get the value 2000 as the final value of the counter, which is fantastic. So this is all about reentrant lock today, and I hope you guys got the point. Definitely we will dig more into deadlocks, and we will check the usage of lock with reference to deadlock in our future videos as well. Hope you guys enjoyed it.